Welcome to students. Good evening. Welcome to the Yupp Master. Today we are going to discuss about that refraction of light through the curved surfaces. So in the earlier classes you have been learned about that reflection. You know, the phenomena of refraction is going to be highlighted in the spherical mirrors, in plane mirrors, in the image formation. So the refraction is having the phenomena bending of light rays. You have to learn. If you are going to take that substances, the density is not at all same. So in different kinds of materials, the refraction phenomena is going to be different. Let us discuss deeply what is refraction. Please have a look into the matter. Yeah, refraction through curved plane and surfaces. If you are going to take that, refraction of light through the plane surface is going to be highlighted. If you are going to have a look, so you can take that light. If you are going to talk about that light, light is a form of energy which is going to be emitted from a source. It travels in the straight line path. It is going to travel in the straight line path. It travels in the straight line path. So how it is going to be examined? In straight line path. Suppose you have taken, this is a glass material. This is the glass material. You have taken this material with a uniform density. Now you can take one light ray. This is going to be travel, that light ray. This is the light ray. So in between these two, the light ray will travels in the straight line path. Whenever you are going to extend that light ray to another medium, let's see, within the same medium it travels in the straight line. Suppose if you are going to take that, this is a one interface. This is the glass and this is the air. What happened? When light enters from one medium to another medium, what happened? Let's see. This is the incidented light ray. Let us assume it's going to be refracted. It's going to be refracted. So whenever you have taken what happened? When light enters from one medium to another medium, when light travels within the same medium, what are the differences? What is your observation? You are going to have a look into the matter. Whenever light rays are going to be allowed to move in the same medium, there is no change if the density is the same. Suppose light rays are moving in water, in glass, in diamond, in quartz, Suppose light rays are moving in vacuum, light rays are moving in the any medium, there is no change. So, there is no bending of light rays, no change in its path, it is going to be moving in the straight line path. So, there is no change. What happened? Whenever it is going to be allowed to enter into another medium, so we are going to allow the light to pass one medium to another medium. What are the changes? What are the observable changes that you have been noticed? First thing, the direction of the light is going to be changed. That phenomena is known as refraction of the light. So, refraction, if you are going to take that, two things, refraction, please take that, it is restricted to two media, it is going to be related to two media, related to two medium, it is going to be related to two medium. While you have learned that reflection, if you are going to take that reflection, you have to take that only one medium. Suppose you have been taken that, you have incident to the light rays, there the reflection has been takes place. The light rays are reflected from the surface, but the refraction which is going to take that related to two medium. So, the refraction is the phenomena which is related to the two mediums. You can take that, one is the rarer medium and the denser medium. Suppose you can take that density of the one medium is low, density of another medium is high, that is the case. So, if you are going to allow the light rays to enter from high density material to the low density material or low density to the high density, what happened? There exists a refraction. Light is allowed to move into different media, whatever the density, not at all same. So, there exists a change, that is its path, change in its path. Why? You have to notice the speed of light in all the materials is not uniform. If you are going to take air, if you are going to take water, that is different. Here what we have discussed, first if you have taken the light in the same media, it is traveling with the same speed and there is no change in its direction. If you have been noticed that change in the direction means change in wavelength. Very simple observation. If you have taken a moving body, changes its direction. Suppose if you are an object is moving, suddenly it is going to change its direction. What happened? Can you observe? There is a change in its velocity, then only it is going to be change in its direction. So, if you are going to have a look into the matter, please have a look. So, light is going to be travelled into different media. If you are going to have a look into the matter, reflection and refraction, in the earlier classes you have learned about that reflection. Generally, if you are going to take that silver metal surface for a mirror, it is going to have the best reflector. The incident light ray from the surface, it is going to be reflected. So, refraction is extended to another medium. So, let us see that refraction in your daily life. If you are going to get the changes in the size of image. So, examples are there. If you are going to be immersed that one pencil into the glass of water. So, the pencil has been immersed into the water which has been kept in a glass. It is going to be bending. That is a common observation. So, actually the object is going to be bent? No, only the light rays, so that it seems to be bending. But you take away the pencil, which is not at all going to be observed, same. Only the light rays, the path of the light rays is going to be bending, changed. Simply the path has been changed. That is the case, you can take that. Yeah, please have a look into the, this is a line which separates that two media. A plane surface, let us take that. So, what is the use of this normal? This is a normal. What purpose that we are going to take that? It is used to measure that angle of incident, angle of refraction, angle of reflection also. Now, you have to take that, this is the first medium. Let us see that. Yeah, this is a one point which is going to be observed, that the point of incidence, point of incidence. Let us take that incident ray, which is going to be incidented on one point, which is at the surface, the plane surface, or at the boundary. Let us assume this is medium 1 and medium 2. What happened? It is going to be identified. There exists a refracted light ray. This is going to be known as refracted light ray. Have you seen that the original path is going to be in this direction? What happened? It is going to be changing its path. So, there exists a bending. Suppose if you are going to take that, this is a medium 1, this is a medium 2. Have you seen a light enters from rarer to denser medium? Yeah, this medium is a rarer medium. This is a denser medium. Suppose light enters from denser to rarer, what happened? This is a normal, what we have taken. This is the normal. With respect to normal, it is the angle. Light is going to be bending towards the normal. This is the normal. When light enters from rarer medium to denser medium, say air to water, suppose it is going to be air medium, water medium. Simply how you will decide between the two media, if you are going to get that, which is the rarer, which is denser, the speed of light is more in the rarer medium. In medium A and medium B, between A and B, the speed of light is more in which one? You will confirm it is the rarer medium. Suppose you can take that water and glass. If you are going to take water and glass, the speed of light is not at all same. So, in a particular medium, the speed of light is more, that is known as going to be rarer one as compared to another. Let us have the discussion. So, this is a case that the bending of light ray towards normal. Suppose if you are going to take that, this is a one surface. So, you can take that, you have seen that this is a one case, this is the denser medium, this is the rarer medium. What happened? You have to take that, the light ray is going to, this is going to be, this is refracted. What you have seen that? This is the right ray. It is going to, what about it is moving towards the normal, it is moving away from the normal, moving away from the normal. So, whenever it enters from, let us take that this is the glass medium, this is the air medium, let us assume. So, it enters from denser medium to rarer medium, the bending, it is going to move away from the normal towards the normal. You have to observe that the case of refraction first one, the case of refraction in second one. So, when you have taken that rarer to denser, it is going to move towards. Same thing you can expect that you are going to reverse it. Whenever light is going to move from denser to rarer medium, what happened? So, the refracted ray moves away from the normal. So, what can you conclude that? The angle of refraction is going to be alpha 2, it is less in case of rarer to denser. The angle of refraction will changes, simply you will find out that angle of refraction is changes in this case, it is very clear. So, what we have discussed, whenever you are allowing the light to move from one medium to another medium, so there exists a bending of light ray, there exists a change in its path. How it is going to change? With respect to the normal, you will measure the angle of refraction. Here the angle of refraction is going to be small, here the angle of refraction is going to be, here you can take alpha 1 and alpha 2. So, this is going to take that, in this case refraction is more, in this case it is less, we will discuss. Yeah, bending of ray, light is going to travel from one medium to another medium, is called refraction of light. Suppose if you are going to take that light travels from one medium to another medium, what are the major changes that occur? So, we know that light travels in a straight line path, this is true as long as in the same medium. So, in the same medium it is true light travels in the straight line path and same density throughout the material. If you are going to take that same density, if you are going to take that material same density means, so in this region you have to take that 4 atoms, you have to take that 4 atoms. So, you can take, this is that same density. So, you will find out that atoms are there, yeah, per unit, atoms per unit volume. If you are going to take that density is the same, then only light is going to be moving in the straight line path. If density is not uniform, what happened? The path is going to be changed. As compared to air and glass, as compared to air and water, which is having that more density, obviously water and the glass. So, whenever light is going to be entering, there exist changes. We are going to discuss. Yeah, light is going to be entered. So, light enters from air to water medium. It is going to be bending. In the same case, you can observe one phenomena. From the bottom of the glass, from the bottom surface, light is going to be again refracted. Simply, it is going to be refracted from water to air. So, lower density, higher density. So, from the air to water, it will going to refraction. Whenever it is enter from air to water, there exists a refraction. Whenever it is going to enter from water to air, from the surface it is going to be refracted, some part of the light is also going to be refracted. It can be viewed, the refraction takes place while light rays are entering from water medium to the air medium. There exists a refraction, light rays enter from air medium to water medium. So, the bending has been takes place due to the phenomena, actually the pencil has not broken, it seems to be, it appears to be broken, that is very clear. So, we can confirm that it is very clear. In this case we will conclude the matter. So, bending of light when it travels from one medium to another medium. Let us see that next one. However, light rays are made to go from one transparent medium to another transparent medium. The light rays change their direction at the boundary. Yeah, at the boundary they are going to, this is the boundary, let us discuss. This is the boundary. Yeah, this is the boundary, we can take that. At the boundary there exists a change in its direction. At the boundary it is going to start bending. You can confirm. Now, let us go for another one. For example, when light ray travelling from air to another medium, say glass, so there exists a change in direction, that is very clear, what we have discussed very clearly. Now, you can take that next one. Refraction of light is confirmed. Yeah, you can take that, light is going to be entered, refracted, it is very clear. Now, medium 1, medium 2. Examples of refraction of light. So, in your daily life have you been observed that what are the observable changes when you are looking into the pond, when you are looking into the swimming pool, what happened? So, the level, the ground has been appeared shallower, that is going to be appear, the height is going to be raised. Simply the bottom of the tank or the bottom of that swimming pool is going to be appeared raised. If you are going to take that actual height is going to be 10 centimeters, the apparent height due to the refraction it is going to be appeared as 8 centimeters, you will find out that. You cannot estimate that actual depth, sometimes it might be having that injuries. While the people are going to jump into the swimming pool, what happened? They might be estimating it is lower, but it is going to be actual height is higher than that of apparent height. So, due to the refraction, the bottom is going to be raised, it is very clear. So, appears to be raised due to refraction. Yeah, it is going to be raised due to refraction of light, which takes place when light rays passes from pool of the water into the air. The light rays are coming from that water medium to air medium. So, what happened? You have to observe that there exists a change in the apparent height. So, you have to observe that change in the height of the that lower. Now, you can take that another example. When you have seen the letters are going to be appearing in different size, while you are trying to read that letters or read the information, while you are taking the help of the glass material, you have been seen through a glass material. Normally with your naked eye, have you seen the light rays? It is very clear. Have you seen that the matter which was written, that information, simply the letters A, B, C or like that, whatever it may be. With your naked eye you have seen, that is the original. With the help of some glass material, have you seen? There exists a change in size. They are going to be appear bigger size. They are going to be appear as a bigger size. The letters are raised. It is going to be raised. When viewed through the glass slab, the letters are going to be raised. from their original position there exists a slight variation, they are appear to be raised. So, this is the consequence of refraction of light. Now, let us take that another example also, pencil, what we have discussed in that. It was immersed, what are the changes? When pencil has been immersed into the water, due to the refraction of the light rays when it comes from the lower level to the air, so from water to air. So, there exists a path variation. So, due to the bending of light rays, it seems to be broken when you dipped into the water, when you have been immersed the pencil into the water. With your naked eye, it is the best example, right? Lemon kept into the water, it is going to be appeared as a big. So, the size of the lemon is going to be increased, appear to be bigger than its actual size. That happened. When you take out that lemon from the water, you have to see with your naked eye, there is no change. But when you kept in the water, its size is going to be appeared as a bigger. That is the phenomenon has been takes place due to refraction, right. So, in your daily life, refraction has been observed. It is very common observation. So, causes for refraction, what happened, why the refraction has been takes place? Whenever light enters from one medium to another medium, what happens? So, you have to see that. So, the basic changes that occurs, change in wavelength, we are going to take that change in wavelength. So, when a ray of light changes its medium, the basic changes occurs in its wavelength. What happened? We will discuss, it is very clear. Now, if you are going to take that, light ray enters from one medium to another medium, this is going to be identified. Yeah. This is the light ray, this is the refracted ray. This is the first medium and second medium, let us assume. Generally, if you are going to take that, you can take, this is the energy of light ray, this is the energy of the light ray. So, there exists a change in its energy when it has been entered from one medium to another medium. Easily you will find out that E is equal to h nu according to Planck's quantum theory, you should learn. So, you will find out that E is equal to hc by lambda, hc by lambda. So, here you will confirm that this is the case E and E dash. So, here let us take that h and c are the constants. You will find out that E is equal to 1 by lambda. Here E dash is equal to 1 by lambda dash. Let us assume. So, as compared to E and E dash, which is lesser, some part of energy. So, due to the refraction, some part of the energy has been lost. That is due to the interaction. What type of interaction? The energy of incident light has been absorbed by the material. Has been absorbed by the material means absorbed by the atoms, whatever it may be. Now, you will go for that E is not equal to E dash. E is not equal to E dash. So, you can confirm lambda is not equal to lambda dash. Either it is greater or lesser, we will discuss. So, what happened? There exists a change in wavelength. Yeah, what is the reason for the change in wavelength? You have been discussed with respect to the energy, it is very clear. While you are going to talk about that next point, yeah. Yes, with respect to velocity also we will differentiate. It is very clear that you will go for E is greater than E dash, E is greater than E dash. What happened when lambda dash is greater than lambda? Yeah, it is going to vary in the reciprocal portion. Yeah, you are going to get that proportionality is in the reciprocal form. That is what you have to take, that lambda dash is greater than lambda, what we are going to take that. Now, it is very clear. Now, you have to take that this change in wavelength leads to the change in velocity. You have discussed why the wavelength is going to be changed. It is very clear, the wavelength of the refracted light is changed due to the change in its energy. Now, if you are going to take that, velocity is a one parameter responsible for the deviation. Simply the velocity changes, it is going to bend. So, we can take that lambda is going to changes. Then V also changes. You will take that. So, the change in the wavelength leads to change in velocity. Now, simply you know that V is equal to properties of waves nu lambda. When V is going to change that, here you should confirm, whenever light enters from one medium to another medium, frequency remains same. That is very, very important. Frequency remains same. Yeah, you have to confirm that. Frequency remains same. This is very, very important point which is going to be discussed deeply. So, while you are going to talk about that, frequency, when light enters from one medium to another medium, yeah, light is a form of wave. You have to agree that light has that dual nature, light is a wave. So, this is that nu, let us assume incident light. You have to take, yeah, this is the, yes, this is the refracted, this is the refracted light, wave. We have to talk that. This is the incident light wave, this is the refracted wave. Let us assume that this frequency is nu dash. The thing you have to observe, nu is equal to nu dash always. Why? The frequency of the wave or the frequency of the incident light wave depending on the source only, which is going to be produced the light waves. The frequency is going to be dependent factor. Which one will produce the light? If you are going to take that source, you can change the parameters regarding to the source. Suppose if you are going to change that light parameter, if you are going to take that lamp or if you are going to take any tube light or anything, you have given more energy for that, you have supplied voltage and you are going to change some parameters, then only light frequency will change. So, the frequency of the emitted light rays are going to be depending on frequency of the source, that is very important, not on medium. So, frequency does not change by the medium, it depends on the source of the light which is going to be emitted from the light or candle or whatever it may be. So, frequency remains same. So, this change in the wavelength leads to the change in its velocity, but the frequency does not changes. So, velocity here, if you are going to take that parameter, so you will take that it remains constant, so that lambda changes, then V also changes. By knowing the relation, yeah, it is very important point to be discussed. Wavelength changes, velocity changes by getting that relation. It is very clear, you have to observe that. Now, you are going to be knowing that one important point. Now, if you are going to take, this is the one case, you have been entered the light rays, you are going to be knowing that at a particular angle you have been incidented. Yeah, this is the angle of incidence. So, if you got the refracted light ray, this is the refracted light ray. With respect to the normal, the angle of refraction R is equal to 90 degrees, that is theta R is equal to 90 degrees. Then only you have to confirm that, that is theta I is known as theta C. Theta I is equal to theta C. Please have a look. When you have been incidented the light ray from one medium to another medium, if you have been obtained that angle of refraction is 90, simply if you are going to change that, if you are going to obtain that angle of incidence, changing the angle of incidence at a particular angle, you will get the angle of refraction 90. At particular angle you are getting that angle of refraction is 90, that is called critical angle. It is the angle of incidence at which that the angle of refraction becomes 90. Simply you have to estimate this is a critical angle, theta C is the critical angle. So, if you are going to talk about that angle of refraction which is going to be 90, in that case the angle of incidence is known as critical angle. If you incident the light at all the possible angles, so at a particular angle you will get the angle of refraction is 90. That is the case we have to discuss. So, among all the angle of incidences, critical angle is different. Why? At critical angle you will get the angle of refraction is 90 degrees. So, simply you will talk about the critical angle, it is the angle of incidence at which that angle of refraction becomes 90. At which angle the angle of refraction becomes 90, it is known that critical angle for that medium. So, if you are going to take glass, one critical angle, if you are going to take water, for a different medium the critical angle is going to be varied, you have to see that. So, in the next classes also we are going to take that complete explanation of all these topics, why lambda will changes, why velocity will changes, light enters from, why not the frequency does not changes. we have to discuss. So, please have the patience. If you are going to have the continuous watching these videos, you are not supposed to miss that one of the video. Please have that regular monitoring and convey to the students and convey to your well-wishers about this Yupp Master. Please, you have the great opportunity to learn all the reasons behind these changes. In your regular occasions, in your regular times, you are not having the chance to learn. Please, by this time you should learn and utilize this opportunity. Thank you very much. Have a great day.